Hello, thank you everybody. Our next speaker is Dustin Ingram. He's a member of the Python Packaging Authority and maintainer of PyPI. Thank you.
Hey everyone, so I'm Dustin. I'm director at PromptWorks in Austin, Texas. I'm a PyTexas organizer. I'm also, like he said, a member of the Python Packaging Working Group, Python Packaging Authority, and I'm also a maintainer of PyPI. So I had a kind of hard time coming up with the title of this talk. And not just because naming things are hard, even though naming things is hard. The reason I had a hard time coming up with the title of this talk is because I knew I wanted to talk about Python packaging, but a lot of people have already given talks about Python packaging. So many, in fact, that every time I came up with a title for this talk, it seemed like someone had already given that talk. So at first, I thought, what is the core of Python packaging? I'll call my talk Python Packaging, Getting the Code You Wrote to the People That Want It Using the Same Language You Wrote It in. This has been done. And that title's pretty long, so maybe I should do something a little more clickbaity, like Python Packaging in just 5 easy steps. That's been done too. I thought maybe I could one-up this person. I could do Python Packaging in just 4 easy steps. He did that as well. So maybe I should be more encouraging about packaging. Python packaging, it's relatively painless now. Go ahead and use it. This has been done. But relatively painless is still painful, so maybe I thought I should try to instill more confidence that it's improving. Python packaging, we're still trying to make it better. That was kind of already done. All right, maybe I should take a stronger approach. Python packaging, let's just throw it all away and start over again. That's been done. Maybe the problem is that too much has changed too quickly. So I'll do Python packaging. Let me just get you up to speed on everything that's changed since last time. That's been done. And then I figured maybe not everyone cares about everything in Python packaging. So I'll do Python packaging. There's a lot of stuff under this umbrella. You might not need all of it. And that's been done by this great talk. So maybe I should keep it simple. Python packaging in the simplest terms possible for anyone that cares. No, it's been done. Maybe simpler. Python packaging, so easy a caveman could do it. That's been done too. All right. At this point, I'm really starting to run out of options. Maybe I should stick to something more unique about my personal experience. Hello, I'm a PyPI maintainer. At the very least, I should be able to tell you how to use PyPI. This has been done. All right. One last-ditch effort. Python packaging, but I'll make it Indiana Jones themed, and I'll do it in French. There's no way this has been done before, right? All right. Okay, so it really kind of seems like everything that could be said about Python packaging has already been said. So I should probably just give you links on YouTube to all these talks. You can go home and watch them, and we can just wrap this up right now. Cool. So in the end, I picked this title, which is actually a pretty awful title for a number of reasons. First of all, it's got an obscure reference to something that makes no sense. Why am I talking about Cheeseshop? I know nothing about cheese. Second of all, Python packaging is an incredibly broad and complex subject. Trying to explain how it works is perhaps a lost cause. And third, I'm kind of making the assumption that Python packaging actually works, which has historically been the biggest complaint about the topic. But here's the thing. I think that Python packaging actually works great, and we've just gotten used to how good we have it. So I really truly do want to do some Python packaging archaeology with you all, and I want to talk about the evolution of packaging through the years to provide some context for why things are the way they are, and about how at each step we had a new problem to solve, and then a new solution for that problem, which begat a new problem, on and on. So let's go back in time. Back in a time when Python was brand new and everything that we're familiar with today in Python packaging didn't exist. Back to the beginning when there was just Python. And pretty soon as there was Python, there was something written in Python. So let's pretend that you're the author of this totally awesome library. Nice work. But really at the moment, this code is only really useful for you. So you have a problem. How do you get this code to your users? This is really the fundamental problem of packaging. So maybe you talk to your friends and you say, hey, I have this totally awesome library. How do you get it to them? You could email it to someone every time you met someone that wanted it, but that would pretty quickly become a pain. You could put it up on your website somewhere with a link to download, and this could be nice because you could add documentation and other things, but how are people going to find it if they want it? Python was first released in 1991. Google wouldn't be around for another 6 years. So this leads us to a new problem. How do I find Python code? What we need is a place where people can go to find interesting Python code, some sort of like index for Python packages. I think that we'll call it the Vaults of Parnassus. So this was the first index for Python software. It's beautiful, right? It's got the Python up there and everything. It's literally an index. So this just linked to something on other people's websites. And I hesitate to use the word package here because at this point, what a package is really loosely defined. The end result is just whatever those people, those maintainers, felt like putting up on their website. There's no standard, there's no enforcement of any standard or quality level or anything like that. And this leads us to a new problem. How do I build this? So at this time, every project came with its own little special snowflake way to build it. Maybe it was a Python script, maybe it was like a make file, and maybe it was just instructions in a text file. This is really painful for users. The solution to this problem was at the 1998 International Python Conference, which is now called PyCon. A little project got started called distutils, which stood for distribution utilities. This was included in the standard library in Python 1.6, which came out in 2000. And this gave us a kind of a familiar incantation, Python setup.py, whatever. I think some people have run this command without really even thinking about what's going on here. It's just a Python script with a little magic thanks to the standard library. And the idea was, why write a domain-specific language or create a new config file when you already have the full power of Python at your disposal? Let's just write more Python. We'll see why in a second that was problematic. And so it was really just a build tool. You'd set up Python setup.py build, and it would replace those make files and everything else. And the goal was just to make something in a consistent way that could then be installed. Distutils also gave us a way to package up source code for sharing, which we called source distributions. This is just a compressed archive like a zip or a tarball. This is also known as an sdist, or I like to say it like a snake, stist. And this command might be more familiar to you, Python setup.py sdist. But it was quickly obvious that sometimes source distributions weren't just going to cut it. The main problem is that sometimes building takes too long. Sometimes source distributions are fine, but sometimes they have so much to do during this build step, possibly even compiling C code, that it becomes really costly to do this every single time you want to install a dependency. And it feels really wasteful if you're doing it over and over again on the exact same architecture. So the solution to this problem was build distributions. So instead of a source distribution, you take a built distribution that's already been pre-built for your architecture, and you just drop it in place. There's no build step necessary. It's already been done for you. This is also known as a bdist. And you create it with this command here. So distutils is pretty great. Having a consistent way to build things was immensely helpful, but it punted on solving two really key problems. The first of which is the generic idea of packaging. By this I mean, how do you get the user to the state right before they run this command, this build command, where they have everything that they need, but they haven't put it together yet? The original distutils authors saw this as a solved problem. All the platforms they wanted to run Python on already had system-level package managers. I'm talking about Linux package managers like RPM. They couldn't imagine that developers would ever want to do development on platforms that didn't have a package manager of its own. Well, guess what? Turns out developers love developing on platforms that don't have official package managers, like macOS and Windows. And there's another problem with solution as well. So maybe your platform does have a package manager, but packages in platform distributions usually lag behind in releases, because once the author has published the code in some way, platform maintainers need to take that and package it up for the specific platform, put it in that platform's specific index, and this takes time. And as a user, generally, you want that fresh release right now, especially if it is a security update. So the solution is the Python package index, a package index that is just for Python. And we call this the Python package index. This is what it looked like in October 2002. And this is great. It gave us a consistent, official, centralized place to put Python software. And I say put because it still links to externally hosted files, but it's got a bit more structure. This is also known as PyPI. Say it with me, PyPI. Not PyPI, that's something else. Again, naming things is pretty hard. This is also known as the Cheeseshop, and this is a reference to a Monty Python skit where a man goes in a cheese shop which has no cheese for sale. The joke is that when PyPI was first created, there was nothing in it. So it's not really even appropriate to call it that anymore because PyPI now has hundreds of thousands of packages. The other thing that distutils punted on was being able to specify dependencies. There was no way to say that a given package depended on some other package being installed as well in order for it to work. And this kind of makes sense. They didn't have a centralized index to point to. But now that we have a package index, it's possible to not only point to some version of an exact package somewhere, but it's also possible to distribute something that does more than distutils, which again was just in the Python standard library and came with your Python. So the solution to this problem was setuptools. Setuptools essentially monkey-patched distutils in the standard library. And there are some advantages here. It's quicker to get new code to users who don't have to upgrade their entire Python distribution to get new packaging goodness. But there are also some disadvantages. Monkey patching is never really a great idea, and especially if you're monkey patching the standard library. But once we had setuptools, all sorts of other things came along with it. One problem that we were having, how can we make installing easier? Now that we can easily specify dependencies, we want to make them easier to install as well. The solution was something creatively called easy install. And this did, in theory, make it easier for users to install various projects. When paired with setup tools, this would allow users to install dependencies for a project directly from PyPI. And it also introduced a new type of built distribution because the existing ones weren't cutting it. This is called the egg distribution. There are other types of eggs, but the built distribution type is kind of the important one here. And an egg is just a zip file with some metadata. It could contain some Python bytecode as well, so then it's prepared for your system. The name comes from Python. Pythons lay eggs. But easy install gave us some new problems. Lots of problems with easy install. It was really good at installing. It was so easy. But it couldn't uninstall. And it couldn't tell you what you had installed on your system. It also mucked around with sys.path, which is just generally not great. So the solution was a project called pyinstall. And you might have never heard of this because pretty much as soon as pyinstall was created, we had a new problem. The name pyinstall is too long. And also typing pyinstall install seems really redundant. Like I said, naming things is hard. So we changed the name pretty quickly. Pyinstall becomes pip almost immediately. And the name pip isn't an obscure reference. It stands for pip installs packages. So we swapped the redundancy for a recursive backronym. So while easy install is still around at this point in time, pip soon becomes the preferred installer. And pip ignores eggs entirely, only installs from source distributions. This is mostly due to some bad rap that eggs got due to easy install. At this point, people are using pip to install dependencies for applications, not dependencies for other packages. So essentially, an application, there is no top-level project to install where you can specify all the dependencies. So if we want a way to specify dependencies for an application instead, what do? Pip introduces requirement.txt, which includes pinning specific versions of dependencies. And this should seem familiar to everyone. This incantation, pip install -r requirements.txt, would install all the dependencies listed in that file. And it allows for semi-reproducible environments. So now everybody is really happily pip installing, but we have a new problem. Installing from PyPI is starting to get really slow. Remember, it's still just an index. So when pip has to install something, it has to go and crawl PyPI, and then go and crawl a bunch of other domains. Those domains might not be performant, and for that matter, PyPI might not be either. Another problem that this introduces is that as a package maintainer, my users have to trust third-party domains. So what happens when I forget to re-register my domain name that my package is hosted on? An attacker can go and register it, put malicious code in its place, and my users have no idea. They are so used to pip trying to connect to random domains that they'll never notice. So the solution to this problem is that PyPI begins hosting releases itself. And this is specified in a PEP 438, which means that PyPI now literally hosts distributions. And around this time, we start to notice a new problem as well. We actually do need built distributions again. Turns out all the problems that we needed built distributions to solve are still problems. But we don't want eggs. Eggs are poorly defined. And file naming conventions are not enough to capture all potential platforms. And like I said, they've been given a bad rap. So the solution is another built distribution, the wheel distribution. It's a lot like eggs. It's also just a zip file. But most importantly, it has a specification. And this specification has learned from all the mistakes of easy install and the egg distribution. The name comes from a wheel of cheese. You put wheels in a cheese shop. I like to think that the authors of this spec actually really got this name right because, in addition, nobody can say they're going to reinvent the wheel. So at this point, a lot of people are depending on PyPI. We start to become a little more focused on making sure it's secure. One problem at the time, Python setup.py upload is not using HTTPS. This means that your PyPI credentials could be intercepted, or that you might not actually even be talking to PyPI at all. The solution was a project called Twine. In the same vein as setuptools and pip, this is a totally separate package, which is installed from PyPI and is responsible for securely uploading a new package to PyPI. The name comes from tying up packages with Twine before sending them. And this name doesn't really correlate well with what it does. Twine doesn't actually do anything to your package. All the bundling has already been done. It just looks up some information about your package and knows how to send it securely to PyPI. It's kind of more like a package carrier, but naming things is hard. So now we're sort of starting to get a little bit into the modern age, and PyPI is starting to show its age. This is what PyPI looked like in, I keep turning the wrong side. This is what PyPI looked like in 2007, about 4 years old. Here it is about a month ago. Here they are side by side, 10 years apart. There's 10 years between these two screenshots. This is kind of like one of those spot the difference games. So it's not really fair to compare PyPI in 2007 with PyPI in 2018. One big difference that you can't see from this slide is the number of packages. PyPI went from having less than 3,000 packages to having more than 130,000 packages. And in that time, PyPI went from a place to get Python packages to the place to get Python packages. And this included lots of issues with PyPI being down or having outages. And there were lots of things that had to happen behind the scenes so that PyPI could continue to work and continue to look exactly the same. The other thing is, by its very nature, PyPI predates almost all of the packages that exist on it, including all the web frameworks and testing frameworks that you're probably familiar with. So PyPI is 15 years old. It has pretty much no tests, doesn't use a modern framework. To run it locally in development, you have to go comment out large chunks of it. What should we do? Well, we could rewrite PyPI from scratch. Normally, if you ask me if a full stack rewrite of a core piece of infrastructure depended on by hundreds of thousands of users would ever succeed, I would tell you no. But I don't know if anyone noticed, but this actually happened. Thanks. This project is also called Warehouse, as in a place to put packages. The project started more or less in 2011 and had a number of goals, including HTTPS everywhere, including best practices, a modern web framework, and tests. And it officially became PyPI last month. I have to say, this was a tremendous undertaking, and it absolutely would not have been possible to have been completed in a reasonable amount of time without support from Mozilla. So thanks to Mozilla. All right, the end. So that's it. We launched PyPI. We solved all the problems. Good job, everyone. We're done. No, we still have problems. But this is the nature of software, right? Once we build the new shiny thing, we start to realize what else it can do, or what we missed, or what the need actually is. So one problem that we still have, packaging is kind of hard, especially if you are new to it all. There are a lot of different tools and things you've never heard of until maybe today. One solution to this is the Python packaging guide. It is a really carefully crafted and well-maintained guide to Python packaging. You can get it at packaging.python.org, and it will help you do almost everything you want to do in Python packaging. Another solution is Sample Project. This is a skeleton project for your new Python package, and it represents all of the best practices for packaging. Another solution is just general care and maintenance. In general, I think these more modern projects are more well-specified and thus easier to maintain. In addition, there's a serious focus on making these accessible for newcomers too. And in fact, I would say that we have a new problem now. Packaging is a little too easy. I could have called this talk, Python Packaging So Easy a Spammer Could Do It. Because having packaging be hard actually has some unintentional benefits, namely that the folks who aren't truly invested in it can't figure out how to use it. Unfortunately, this also excludes a lot of people that don't have malicious intent. So while lowering that barrier is a priority, it introduces new problems, like spam on PyPI, typo squatting, etc. There's another problem that's kind of common these days. Sometimes I need more than Python. Sometimes I don't even have Python yet. Maybe you need to do stuff with Python and R, or LLVM, or a bunch of other things. Maybe you don't even have Python installed on your system. These things are kind of outside the scope of the Python packaging authority, which kind of assume that either A, you already have Python, or B, that you really just want to do Python with some C mixed in. Solution to this is Conda. And this is definitely within the scope of Anaconda and Conda, which is provided by the Anaconda company. It's a Python agnostic packaging tool and installer, and it satisfies most of those use cases. Another problem we have right now, reproducible environments. Requirements.txt was a great step towards creating reproducible environments. And we can use it to specify exact versions and hashes of any dependency for pip to install. However, creating and maintaining this file can be kind of challenging. Often we have multiple requirements files for deployment, development, testing, linting, documentation, etc. Solution to this, pipfile and pipfile.lock. A single human editable file and a single generated file with fully deterministic dependencies. And this can be shared across multiple dependency installing tools like pip. And this might feel familiar if you come from Ruby or NPM ecosystem where you have gemfile.lock and yarn.lock. It's kind of a similar idea. Another problem that we have right now is that setup.py executes arbitrary code. And this is because setup.py, like I said, is just a Python script. There's no way to truly predict what dependencies a package will have without executing it. I see questions like this so often that I wrote a blog post about it. And the answer is, the blog post is called Why PyPI Doesn't Know Your Project's Dependencies. And the answer is, you can do anything you want in a setup.py. And this makes it really hard to reason about source distributions. And there's an additional problem with setup.py as well. And I'll call this problem the distutils setuptools dance. So extending and maintaining them is really difficult. Distutils, because it's a core Python library, comes with your Python. And setuptools because it's old and kind of a big ball of mud right now. So while there do exist various solutions to the above problems, they're really hard to implement and even harder to maintain. And also, it's really difficult for anyone to use anything else, because they are essentially the de facto standard interface for doing Python packaging. Changing it is kind of like a chicken and egg problem. The solution to this problem is PEP 517 and 518. They're defined where they define a build system independent format for source trees and a way to specify minimum build system requirements for Python projects. This is going to manifest itself as a new file called pyproject.toml. This is a way to step away from distutils and setuptools entirely and allow users to specify their own build requirements for their project, which can be installed prior to building. It could be setuptools, but it could really be something else entirely as well. That sounds like a lot of problems, you might say. And also consider that unlike Conda or NPM, and with only a few very small exceptions, Python packaging is an entirely volunteer-driven team. So maybe you'd like to help. Both PyPI and pip have good first issue labels in the issue tracker. So if you want to become a contributor today, you can do that. If you want to become a contributor like next week, we're going to be sprinting on packaging things Monday through Thursday. I will be there. I have a whole list of things that just about anybody can work on. And I'm going to be really happy to help anyone get set up and to make a contribution. We're also holding a packaging Birds of Feather immediately after this talk in room 19. Several maintainers of various packaging projects will be in attendance. We're going to talk about general direction and future of packaging, and it's open to anyone. I've told you how to help us. Here's how we can help you. If you're having problems, you can do any of the following things. Like I said, you can go to packaging.python.org. You could go to an issue tracker for a specific tool that you're having problems with and file an issue. You could go to IRC, to the #PyPI channel on Freenode to chat with any of the maintainers directly. Or if you're having sort of like a big holistic problem with packaging, you can go to the packaging problems repo and file an issue there. And these are sort of in order from how quickly you need the problem solved, from very quick to it might take a couple years. The other thing you can do is you can talk to me. I'm really happy to help. So I'm on GitHub as DI, Twitter, DI codes, and email is there. So to summarize, Python packaging isn't bad, but there are always going to be problems to solve. We've made really gradual changes over a long period of time, and each change has been a response to an evolving need. Comparatively, it used to be really bad, and we might have forgotten or just never known how hard it used to be. So the next time that you are frustrated with Python packaging, imagine a world with no pip, no PyPI, and consider making a pull request. Thanks.
Thank you,
I'm gonna-
Dustin. We've got a few minutes for questions now, so please come to the
Yeah,
microphone if
actually,
you have.
I'd like to, I'll skip questions. I'll be at the packaging booth if anyone wants to talk to me, and immediately down here afterwards as well. Thanks, everyone.